Good morning, guys. Today we are going to start second chapter of subject object-oriented software engineering. Chapter number second is Introduction to UML. UML means Unified Modeling Language. It stands for Unified Modeling Language. It is not dependent on any one language or technology. This UML is not dependent on any one language or any technology or any platform. Okay. It is a diagramming language designed for object-oriented programming. This UML is a diagramming language. It is designed for object-oriented programming. As its name says that unified modeling language. It is a modeling language that contains or that combines various approaches in a single design language, which is used to plan and create computer application. Whenever we are going to create any computer application, whenever customer comes with their requirements, we are going to use this diagramming language for, that is unified modeling language, that is UML, for designing the diagrams or drawing some diagrams based on that system for that application. Okay. UML is actually a combination of several notations like object oriented design, object modeling techniques, and object oriented software engineering. Okay, it is a combination of these notations. This is UML, that is Unified Modeling Language. The next one is UML diagrams. Sorry. Why we use UML? Why? What is the necessity of using UML? It is widely used modeling language in the field of software engineering. In software engineering, it is necessary to draw the diagrams for the system. For that, we are going to use the modeling language, that is UML. Expert uses UML to analyze, to design, and to implement the software-based systems. It is most often used for determining system requirements and planning details of system implementation. UML is used for to determine the requirements and plan the details of the system implementation. Through UML, we can get through UML we can get the help of that. We can see the overall view of the system by by using that diagram. We can get the total information or total workflow of the system. We can get how we can see the how program executes through the diagram, how program is used, how program is deployed over a network. We can build and guide the creation of complex system through the diagram. Through the UML diagram, we can get the overall view of the application. Okay. See this diagram, UML diagram types. There are two types of UML diagrams. One is structural diagrams, another one is behavioral diagrams. Okay. So structural diagram consists of composite structural diagram, deployment diagram, package diagram, profile diagram, class diagram, object diagram, component diagrams. These are the structural diagrams. And second type is behavioral diagrams. Under behavioral diagrams, state motion diagram is there, communication diagram, use case diagram, activity diagram, sequence diagram, timing diagram, and interaction overview diagram. There are two types of UML diagrams. First one is structural diagrams, second one is behavioral diagrams. So these are the types of UML diagrams. Okay. So we will see what is structural and what is behavioral diagram. So structural diagram that shows the things in the system being modeled. Okay, what is the structure of that system? That structure or the things inside the system is going to be modeled in structural diagram. In more technical terms, we can say that this diagram shows the different object in the system. There are different object in the system. Through structural diagrams, we can show that. Then behavioral diagrams. The behavioral diagram shows what should happen in system, that is behavior of the system, how system behaves. Okay, what system is going to do, that is the behavior of that system. That behavioral diagram shows the behavior of that system. Okay, what should happen in the or inside the system. They describe how object interacts with each other to create a functioning system. That means in structural diagrams we are going to show the things in that we are going to show the things in a system that we model, or we are going to show the different object in the system. Or in behavioral diagrams we are going to show that how that objects from the structural diagram, how that objects are going to interact with each other to create a functioning system. These are the structure and behavioral diagrams. Okay, so we will see one by one. First diagram is use case diagram. Okay, Use case diagrams gives a graphical overview of the actors involved in system, different functions needed by those actors, and how these different functions are interacted. Okay. So in this diagram, you can see that there are some actors. Okay. These are the actors. Okay. Surgeon, nurse. Consider the system for hospital management. Okay. So patient is there, receptionist at hospital, receptionist is there, doctor is there, surgeon is there, nurse, okay, or admin is there. Here, consider the scenario: patient comes to the hospital for taking appointment, then receptionist will take that appointment. The circle or this ellipse indicates that this is the use case. Okay, this arrow is the associations. Okay, then after taking the appointment, that surgeon is going to or doctor is going to take the treatment or give the treatment to that patient. Okay, so what surgeon will do the operation based on that, or it assigns the operation to the next actor, that is nurse. Okay, so there are, this is the generalization, takes the treatment or what kind of treatment. Okay, so there are several types of treatment. Okay, delivery, normal treatment, or diagnosis, any type of diagnosis. This is the generalization. This arrow indicates the generalization. Okay, is a association. Okay, next one is admin is going to generate the bill. Okay, admin is going to generate the bill based on the treatment. Then patient will going to pay the bill in the form of by cash or by credit. Okay, this is the use case diagram. Through this use case diagram, we are going to understand the scenario, that is what is the system actually it is. Okay, we can understand what is the system, how system behaves, or how system, what is the flow of that system. This is the use case diagram. This one is the actor, this is use cases. Okay, this is the generalization terms. Okay, this is the use case diagrams. The next one is class diagrams. Class diagram shows classes, interfaces, and their relationships. Okay, it shows the classes in the system, attributes, and operations of each class and their relationship between each class. In the in most modeling tools, a class has three parts. Okay, class name at the top, attributes at the middle, and at the end methods. Class name always start with capital letters. Okay, initial letter will be uppercase. Okay, so class name must be noun. In first chapter we have seen that. Okay, so class name, then attributes means the declaration part. Okay, attributes, then methods for functions for that attribute to access that data. This is the class. We are going to declare the class like class name, then their attributes, then methods. Several classes are there in the system, so in this way we can declare the classes, attributes, and method. This is one class, second class. Okay, there are multiple classes, or we can connect those classes with relationship like one to many, many to one, one to one. Okay, these are the relationship between that classes, or we can use interfaces. Okay, to connect that classes. This is for class diagram. The next one is component diagram. This component diagram displays the structural relationship of components of a system. This is the structural information. They are considered a scenario for any order management or product system. So there, this is the component. Like here you can see there are four components here: order, product, customer, and account. These are the components of the system. That component includes several packages. In order component there are several packages are there. In product component there are several packages. For the customer and accounts also there are several packages. We can communicate here. Components communicate with each other through using interfaces. Here you can see both components are communicating through some interfaces. Okay, this is the way how we can communicate with components. Okay, here you can see the payment interface. Okay, payment gateway. Okay, account provides for order, for to do the for sorry to do the payment for that order, we can use payment interface. Okay, these are the components of the system. Here, we can use the component diagrams whenever we are going to implement any complex system. Okay, for complex system we are going to draw this component diagram. The next one is activity diagram. Activity diagram represents workflows in a graphical way. Everybody knows about the flow chart. Okay, flow chart is similar, always, not always, we can say flow chart is similar to that activity diagram. How we can, what is the flow of the system, what are the steps to execute for the system, like consider the scenario that student system. Okay, uh, first we are going to start the system, then we are going to enter the details, we are going to validate the details, we are going to perform some insert, delete, update operations. Okay, then we are going to save the details. This, and at the end we are going to close or end the system. Okay, this is the activity of that system. That means in this diagram we are going to represent the workflows of that system. Okay, there are several activities for that system. The next one is deployment diagram. Here, this deployment diagram shows the hardware of your system. Okay, this diagram shows the hardware. Whenever we are going to deploy the system to customer or at the end user, we are going to deploy the system or machines to or our product to end user. We are going to provide some. We are going to provide some equipments like here for consider the scenario for hospital management system. We are going to give the we are going to provide some hardware components to with that software. We are going to provide hardware components to that end user like consider here the desktop client, then we are going to provide a hospital local server, then database server, then printer. Like this we are going to deploy. Okay, this is the deployment diagram. We are going to whenever this diagram is necessary whenever we are going to deploy the system to end user. The next one is communication diagram. This diagram is also called collaboration diagram in UML 1. This is in next lecture we are going to see the history of UML or some basic things about the UML. This is the just introductory part of UML system. Okay. Previously, communication diagram was called as collaboration diagram. Okay, collaboration. It is similar to sequence diagram. Okay, this diagram is similar to sequence diagram, but the focus is on messages passed between objects. Here you can see there are this diagram is for online bookshop. There are several objects: inventory, book, shopping cart, and order. These are the objects. Here you can see the actor. Okay, we are going to pass the messages between that objects. Okay, here for find the books, we are going to pass message to the online bookshop object. Then this message will be passed for searching message will be passed to inventory system. Then inventory system will do it will find the book from that book object. Okay, then it will add to the shopping cart. Okay, this is the passing message. We are going to pass the messages to the objects. Okay, this is the communication diagram. We are going to pass the message between the objects. Based on the object, based on the messages, objects are going to communicate with each other. Okay, this is the communication diagram. Then next one is timing diagrams. Timing diagrams are very similar to sequence diagrams. Okay, this diagram represents the behavior of objects in a given time frame. Whenever we are going to implement any software or any we are going to develop any software, there is a time period. Okay, at the start we are going to gather the requirements from customer, we are going to analyze that requirement. Okay, these are the stages of software development life cycle. We are going to get the requirements, we are going to get analyze that requirements, we are going to design a model for that requirements, we are going to implement that requirements. Okay, we are going to test that requirements, finally we are going to get a, a quality product. These are the stages. Okay, or for in timing diagrams we are going to mention that stages at for first stage how much time is required, for second stage how much time is required. Okay, the timing diagram shows that time period for each stage. Okay, this is the timing diagram. Okay, everybody understood?